Welcome to the YouTube replay of our Green Drinks August edition. This month we focus on mass timber. What is it and how is it changing the design and built-in landscape? We have four experts in the field joining us to discuss. Tim Buehler from Ontario Woodworks, Patrick Chouinard from Element 5, Marc Gaglione from ELLISDON'S, and SmartNet Alliance member Andrew Melchers from Engineering. Enjoy the replay of Green Drinks August.
So tonight, in addition to our Canadian participants, we have people that are from India, the US, Mexico, and Lithuania. So it just shows us how far we can reach, and I think everybody knows that, but it's nice to see that people are signing up and coming on to these green drinks. For those of you who don't know me, my name is Raymond Demir, and along with Nick Hebb, we are both with SmartNet Alliance. The Alliance is a group of businesses and organizations who collaborate on projects and initiatives to accelerate Canada's transition to a sustainable economy. For more information on SNA, you can consult our website at smartnetalliance.ca, and Nick is going to put that at in the chat box for you. You'll be able to find out more details about our members, and we have recently launched several business courses which you can find on the resources page. Be sure to check out the membership page while you are there, and Nick will put that link also in the chat box. For those of you who are not familiar with Green Drinks, this is an international event that happens once a month in about 500 countries. Now with the pandemic, it's probably a little bit less, but usually that's where we are. There are about 20 chapters in Ontario, and in Ottawa, it has existed for over 10 years. SmartNet Alliance started hosting Green Drinks about 5 years ago at the Fox and the Feather, and now on Zoom. So it's going very well. Again, just to mention again, we are recording the session tonight, and it will be up on YouTube within the next 2 weeks. If you want to, we've got a whole playlist, and Nick is also going to put that in the chat box for you. Tonight, we are focusing on mass timber and on all of its sustainable features. We have 4 guest speakers, and they are Tim Buehler from Ontario Woodworks, Patrick Chouinard from Element 5, Marc Gaglione from ELLISDON'S, and Andrew Melchers of Engineering. In a moment, Nick will introduce each speaker individually before they start their presentation. We are also tonight, rather than doing a general Q&A session after the presenters, we are going to use the breakout rooms. So the presenters will each have their own breakout rooms, and then we will automatically send everybody into a breakout room. If you want to change breakout rooms, you will need to come back into the main session where Nick and I will be there, and we can put you back into another breakout room. And speakers, just a reminder, you're in the breakout room from your speaking orders. So number 1 will be Tim, number 2 will be Patrick, number 3 will be Mark, and number 4 will be Andrew. So if you end up in a different breakout room, can you just come back to the general session and we will put you in the right breakout room. Again, if you have any questions, just put them in the chat box, or you can wait until you go into the breakout room with the speakers. So thank you for being here again tonight. And Nick, I'm sending it back to you for the introductions.
Thanks so much, Raymond, and yeah, great intro. We're excited to have 4 great speakers, and we're excited to do the breakout rooms tonight. So just hold off on your questions, make note, and you'll be able to surf around, and we'll give everybody time to be able to go into each room if you'd like and ask your questions, and it's a little bit more of an intimate setting there too. So first off, we've got Tim Buehler, and Tim comes to us from Ontario Woodworks. He's a technical manager over there. Tim was born and raised in Northern Ontario. He graduated from Nipissing University and shortly afterwards joined the Canadian Wood Council. Tim's keen interest in sustainable construction and curbing climate change led him to pursue the role of technical manager within the Woodworks program. Over the last 14 years, Tim's experience in education has taken him across North America and Europe, where he's engaged and learned from a variety of leading experts in the field. Tim has worked closely with the industry, and he's a great person to lead things off and give us a bit of an overview on the mass timber industry. So without further ado, we'll hand it over to Tim, and he's going to share his screen and get rolling on his presentation. Over to you, Tim. Thanks for joining us.
Thank you, Nick, for the introduction. Let's just make sure, get the screen up here. And you can see my slides okay?
Yes, we can.
Excellent.
Everything's great. Thanks, Tim.
Yeah, so thanks to Nick and Ramon for the invitation to myself and the fellow speakers to talk about mass timber. As we kind of, in our practice session mentioned, I'll be kind of batting leadoff hitter to set up everybody with some of the terminology and history so that we can have a good base for what everyone else is going to be talking about. So just a little quick outline of what I'll be speaking about. I'll just go over the Canadian Wood Council and the Woodworks program, talk a little bit about climate change and what's happening out there in the construction industry, and the development of wood construction to how we got to this term and these products that are considered mass timber, and then the advantages and possibilities with this type of construction. The Canadian Wood Council represents the Canadian wood products industry through a national federation of association, and the Canadian Wood Council provides technical and knowledge transfer services relating to building codes, standards, and regulation. And our vision is to be passionate, credible agents of change, leading to an advance in sustainable wood culture. These are the Canadian Wood Council members. And part of the Canadian Wood Council is the Woodworks program, which deals with some market outreach and education. And we have our own national and provincial sponsors that support our program through their financial and in-kind contributions. So, you know, we used to have a slide that say, well, why build with timber? And now it's somewhat evolved into why not build with timber? We have a safe, strong, sophisticated, and sustainable resource at our fingertips that is a very sophisticated building material. Wood buildings will meet and in some cases exceed the safety requirements of provincial and national building codes. Today's wood buildings and products are extremely durable. Advanced research and technology are expanding the application options for wood products, as we'll get into with mass timber. And wood is the only completely renewable building material that is harvested from responsibly managed forests. So it's a sustainable and environmentally sound building material because of the photosynthesis process. So as trees grow, they remove carbon dioxide from the atmosphere, which is largely retained by the tree and surrounding soil. So if you add water and sunlight, you can grow a building material in 60 to 80 years in our climate, which is a carbon sink producing oxygen as a byproduct. As we mentioned, as the trees grow, they absorb CO2 and release oxygen. It's important to remember that trees have a life cycle like any other organism. So if they die through natural means like insects, fire, or wind, then they slowly decay and release the carbon that was stored. In fact, far more trees are destroyed through natural means than are harvested through forestry. In fact, it's not even close. So some forests are naturally actually a carbon source because of the decaying trees in nature. So if we can harvest them at the proper stage and replace them with young trees that absorb more carbon, we have a nice cycle here that will allow us to produce building materials that will have this carbon stored for the life of the building. By ensuring the trees are replanted, the cycle will continue. So why do we need to focus more on sustainable building materials? The population of the Earth right now is 7.5 billion, but projections say by 2050, we may have as many as 9.5 billion people on this planet, which is staggering, as you know, only about 60 years ago, a population was approximately 3 billion people. So everyone needs places to live, to work, and to play. In construction, concrete production is currently responsible for about 8% of the world's CO2 emissions, which is not far behind huge industries like agriculture. In fact, if concrete production were a country on its own, it would be in the top 5 producers. To put this in perspective, you know, obviously before travel lockdowns, the entire aviation industry was only responsible for about 2.5%. So, you know, the climate reports are out there, the evidence is crystal clear. So we've got to change the way that we're building to keep up with these demands on the planet. So wood's dry mass is actually 50% carbon. So the more carbon we can retain in buildings, the less that's released into the environment, and perhaps this will lessen the impact of climate change, at least in the built industry, doing our part. So talk about using wood in construction and how we got to mass timber, which we're going to be talking about in depth tonight. So historically, we have built with wood because it was readily available, easy to work with, lightweight, and easily transportable. We started building with sticks, classified as dimensional lumber, 2x4s through 2x10s, and so on, with planks used for sheathing. And this worked reasonably well, but there were size limitations, and it's a very labor-intensive process, very much piece by piece. So wood has developed along the way. Different products like engineered trusses allow us to achieve longer spans and have greater strengths. Panelized products like plywood and OSB allow us to cover our buildings more quickly. And engineered products like I-joists and other structural composite lumbers allow us to achieve greater spans and have stronger members. So something worth mentioning, somewhat not generally included in the mass timber family or main players, are the structural composite lumbers, or SCLs. Laminated veneer lumber, parallel strand lumber, and laminated strand lumber. It is somewhat of a mass timber product on its own that has a variety of advantages. They can be made to unlimited lengths in production, much lower moisture content and less prone to shrinkage, greater strength to weight ratio, increased resistance to fire, and less wasteful. You can only get so many 2x10s out of a round tree, but these structural composite lumbers use smaller pieces. These can be used in applications like studs, beams, columns, and panelized products. So these have evolved over many years until we've kind of reached a maximum size with these types of products as well. So this leads us into the mass timber discussion. Catching momentum in Canada and North America in recent years, this has been a popular type of construction since the early 90s in European countries, and even some examples of North America that we'll get into. But it's not quite as new as many people think, but certainly gaining a lot of popularity. The two main characteristics of mass timber that allow us to build these larger and taller buildings are the strengths. So the larger members have a greater load-bearing capacity than any dimensional lumber that we see, and the fire safety performance. So wood, when exposed to fire, behaves in a mass timber application behaves a little bit differently. When exposed to fire, the outer layer will slowly burn, but it creates a natural protective charred layer. So the char layer acts as insulation, which delays the onset of the heating of the wood in the core that's making up the structural capacity of the building. So the char will form at a very predictable rate of about 0.64 millimeters a minute, which will slow combustion and allow for evacuation. So you can easily design a sacrificial char layer into your building to ensure that you meet the fire resistance rating prescribed in various building codes. So just quickly get into the common mass timber products that you'll see. Glue laminated timber, or it's typically known as GLT now, as most of these products will fit into a three-letter acronym. Glue lam is composed of individual wood laminations specifically selected and positioned based on their performance characteristics, and they're bonded together with durable moisture-resistant adhesives. The grain of all laminations will run parallel with the length of the member, and the laminations reduce natural defects and mitigate some common challenges with wood construction. GLT has been around a bit longer than some of the other products, typically used in showcase public buildings. I'm sure all of us at some point have been in an atrium or public space that has some glulam post and beam construction. Glulam has excellent strengths and stiffness properties, can be made in a variety of layups, including curvatures as you see in the photo, and can be used for beams, columns, decking, and other applications. In fact, this particular project highlighted here is a glulam arch in Richmond, BC, part of the Olympic speed skating oval building that has a 100-meter clear span. The next product is cross-laminated timber, or CLT. It's an engineered wood panel, typically consisting of 3, 5, or 7 layers of dimensional lumber oriented at right angles to one another, and then glued to form structural panels with exceptional strength, dimensional stability, and rigidity. And the the alternation of the laminations allow for some strengths in 2 directions, much like a concrete plate can offer. The odd-numbered laminations will offer the greatest strengths. This has been around for 30 years or so in Europe, and recently appearing in North America. Because of its ability to span in 2 directions, it's very well suited for floors and roof structures, and for mid-rise and tall wood construction. This is an example of a building in Quebec City that is made entirely out of CLT, from panels as much as 9 plies in thickness. And it was used for the walls, the floors, the roof, elevator shafts, and shear wall applications. Nail laminated timber, or NLT, is actually, it's over a 100-year-old construction method that is undergoing a design renaissance in the, as part of the mass timber world. It can be found today in many historical buildings, especially in the Toronto area, in all shapes and sizes, with heavy timber post and beam construction, with the nail laminated timber used as a floor structure. This is just dimensional lumber nailed on edge. Obviously, it used to be nailed by hand in place a century ago, but now sophisticated nailing guns and automated machinery allow it to be manufactured to spec in a factory setting. And a similar product to NLT with one important difference is dowel laminated timber, or DLT. Currently, this is the only all-wood mass timber product. Hardwood dowels are used with the softwood boards to friction fit the panel together. So it's particularly efficient for horizontal spans and allows for a lot of architectural flexibility. With no metal fasteners, the panels can easily be processed using CNC machinery, creating a high tolerance panel, which can also contain pre-integrated acoustic materials, electrical conduits, or other service interfaces. This is currently just manufactured by StructureCraft in Canada, in British Columbia. Again, these panels can be used for floors, walls, roofs, and elevator shaft applications. So now that we've learned a little bit about some of the mass timber products, when we look at the possibilities, it's really endless. If you can panelize these wood members, they can act like large plates and have two-way capacity if required. These are highly processed products where some of the natural defects that occur in wood, like checks, splits, knots, etc., can be removed and controlled, and the quality of the finished product can be assured. Moisture content can be monitored in the factory setting to mitigate shrinkage to a large degree. And since you can CNC most of these panels quite easily, connections for MEP can already be installed and prefabricated. They can be shipped to a job site due to their much less weight than steel or concrete quite efficiently and craned into place immediately. Now, suddenly you can erect the entire floor of an office building in a week with no formwork required, no rebar, or hundreds of concrete trucks. You don't have to wait weeks to strip the formwork, and you don't have to reshore. You can use large portions of the structure for the finish and eliminate costly and time-consuming application of gypsum wallboard, and you're all set to go with a really beautiful looking project. And a lot of people think that, you know, we're trying to stress skyscrapers out of wood, which are great, but many of these buildings, which I'll just flip through quite quickly, fit within the prescriptions of existing building codes, like a toy store, a furniture store, a grocery store, libraries, community center pools, office spaces, and even warehouses. So this allows us to have a lot more flexibility and a lot more types of buildings that we can really be proud of. So that kind of puts me at an end for what I wanted to go over, so that we can kind of set up the rest of the speakers for today. So I thank everyone for the time, and I'll be happy to chat with everyone in the breakout room later on tonight. Thanks.
Thanks so much, Tim. It was great to get an overview there. I know it's great to demystify some of those acronyms and give us a little bit more knowledge about how these buildings are built. So thanks so much for that, and looking forward to going a little deeper in the breakout rooms there. So next up we have Patrick Chonard, and I was quite excited to get someone from Element 5, and Patrick is one of the founders, and thanks so much for him for joining us. Element 5 is a Canadian company. They're doing quite a bit on the mass timber, and Patrick is the founder and VP of Business Development for them. It's Canada's newest mass timber fabricator. Patrick's specialty lies in his ability to orchestrate mass timber solutions together with a consortium of the industry's best professional service providers who have experience in mass timber. Patrick's experience in the wood industry is the driving force behind the company, capable of providing integrated solutions that combine access to exceptional quality wood products and a complete range of services. Before founding Element 5, Patrick served as the Director of Wood Solutions for Spring Valley Architectural Innovations. So that's great. So we'll bring in Patrick. It looks like you're coming maybe from your office there, and there's quite a bit of wood there. So that's a nice background to see you. And thanks for joining us.
Thanks very much, Nick. So I'm just trying to switch to my next slide here. Sorry, having some technical difficulty. Pardon me for a moment.
Oh, no worries at all. Yeah, maybe reshare there and that should come up.
Okay. We're in the midst of a revolution in the construction industry, which is characterized by buildings which are being prefabricated in factories and shipped to site for assembly rather than construction. And until recently, the building that you see here was the tallest modern wood building in the world, and it was at the, it's called the Brock Commons Building, and it's at the University of British Columbia. This building was constructed on a concrete podium, and then on top of the podium sat these glulam columns that you'll see here on the left-hand side. And on top of the glulam columns would sit the CLT panels, floor panels, and then above that, more columns, more panels, etc. Interesting about this building is not only is the structure of the building prefabricated, but the envelope panels that you see here were prefabricated as well. And these panels were made in a factory, and the panels included the structure of the panel, the cladding that you see there, the windows and the doors. So as the building went up a couple floors, these panels were hoisted into place and fastened to the outside of the building. So this is an 18-story building, and it was rendered completely weather tight in 9.5 weeks. Just to give you an example of some of the things that are happening, at least here in the Ontario marketplace, there's a lot of excitement about the mass timber industry, and there's a number of buildings that are in various stages of design and development. This is 80 Atlantic Avenue. It's a 5-story office building. It's one of the few buildings that have been built in the city of Toronto out of mass timber within the last 100 years. George Brown College is building a 10-story building on the Toronto waterfront. The University of Toronto is building a 14-story building. Centennial College is building a 6-story building, and I'm sure that Mark will talk a little bit more about this building since ELLISDON has the contract for it. This is a building that soon will be under construction. It's called 77 Wade Avenue, also in Toronto. This company, Hines, they have come up with their own brand of mass timber building, which they call T3 buildings. They built their first building in Minneapolis, another one in Atlanta, and now they're building 2 massive buildings that they call T3 Bayside on the Toronto waterfront. They're building 2 more buildings on Sterling Avenue in Toronto. And I see that Adamo has joined us here, and who knows this project intimately with shop architects. This is the distillery building, or the ribbon building, that's going to be constructed in the distillery district of Toronto. So why all the interest in mass timber? Well, it really depends on who you're asking. If you're speaking with owners and developers, it's all about return on investment. Mass timber buildings have the propensity to be built at lower cost, and in addition to that, tenants are willing to pay a premium to be in these buildings because of these, absolutely beautiful buildings. So the fact that you can build them at lower cost and get a higher premium means that owners and developers are getting a higher return on their investment. Speed of construction, certainly, if referring back to the Brock Commons building that was completely weather-tight in 9.5 weeks, certainly the structure of the buildings go up more quickly than conventionally constructed buildings. In addition to that, when the site work is being done on a building, mass timber buildings are being constructed in a factory at the same time. And when they're shipped to site, they're assembled rather than being constructed on site, so they go up much more quickly. If you speak to the environmentalists, as Tim mentioned, it's all about the environmental benefits. It's all about carbon sequestration and using, natural, renewable, sustainably harvested materials. But there's also the human factor. There are a number of studies that have been done that show that there are health benefits associated with living and working and educating our children in buildings where there's a higher wood content. So I was asked to talk a little bit about Element 5. We are a startup company, essentially. I started the company at the end of 2019, so we've been operational for less than 5 years. One of the first things that we did, and fortunately we were able to buy the assets and all of the equipment of a small CLT manufacturing company that's located in Ripon, Quebec, which is about an hour due east of Ottawa. It's a small facility. It's about 13,000 square feet. This is CLT manufacturing 101, and if you look at the top left-hand corner, what you'll see is a vacuum press. This is basically a bed that you lay the materials in. You have automated glue applicators that put glue on the surface, and then you have this rubber membrane that you drape across the bed, and you fasten down with these fasteners that you see around the outside, and then we suck the air out of it, and that creates compression on the panels until the glue's set. With this process, we can only manufacture about 3 panels per day. So it's a pretty slow process. And then we pick up the panels with the overhead gantry that you see there, and then we move them to other parts of the factory, and then we hand frame everything. We use hand tools basically to cut everything to size and shape. We quickly learned in this industry that in order to manufacture panels, there are very few architects and engineers that know how to design and engineer mass timber buildings. So we realized that if we wanted to ultimately sell something, we had to handhold these projects from early stage design through to the point where we could actually manufacture materials. So we're a full service organization. We provide cost consulting, design consulting, engineering, 3D modeling, shop drawings, fabrication, and we also quickly learned that there are very few companies in the industry that know how to put together these buildings. So we ended up having to take the contract for the assembly of these buildings as well. This was one of our first projects, a small commercial project in Orillia. It's called the Waterfront Center. When we sold this project to the general contractor said, well, you know, how long do you think it's going to take to put this building together? And honestly, we had no idea. We said, oh, well, 4 days, I guess. And the materials were delivered to site on a Wednesday morning. By noon, all of the glulam columns and the beams that you see here were assembled. And by 5 o'clock, all of the CLT panels were on the roof. And so this entire structure only took a day to assemble. And at that point, we knew that we were onto something. This is the first project that we did where we used CLT for the exterior walls. This is a cafe in Gatineau, Quebec. We started to get into the commercial market space. We sold this to I believe it was the Ministry of Environment. This is an entirely CLT little structure. It's a bird banding station. And this entire structure was erected in a single day. A little more on the commercial projects. We provided all of the structure for this flat building on the front of the Pharmacie Brunet, which is a health center and a spa. And this is what the building looks like on the inside. Photo on the right. This is the first project that we did where we sold NLT. So this is a hybrid structure. It's a steel building, and we supplied all of the NLT panels that you see here. This is called the Living Libations Building, and one of the challenges with CLT is if you have to span long distances between structural members, you have to increase the thickness of the CLT considerably. And if we were to have sold strictly CLT for this project, it would have been cost prohibitive. So we came up with what we now call box panels. They're hollow core CLT panels that have a CLT slab on the bottom, a CLT slab on the top. There's an engineered joist in between, so these panels are actually hollow in the inside. So they're actually stronger than CLT, and because they're hollow, it's a solution that's much more cost competitive against concrete. We recognize that there's a need for about 130,000 houses for First Nations communities across Canada alone, not including what's necessary in the United States. Certainly some challenges to be able to build in these remote communities, and it made sense for us to prefabricate homes out of CLT. We also introduced with this project what we call our CLIPS panels, which stands for cross-laminated insulated panels. And these are panels that come with a CLT interior layer, the insulation pre-installed, and then optionally the cladding in the windows and doors installed. So we flat packed this home and we shipped it to New Brunswick. And this was the first model home, ultimately for the sale of homes for First Nations communities. The next major CLIPS panel that we sold was for this project. It's the Oakville Fire Hall. This is currently under construction. The back section of this building is out of steel, and the front section of this building is a post and beam structure. We sold our CLIPS wall panels for the entire building that you see here, and we supplied what we call show sugiban siding. It's burnt wood siding. So interestingly, this is a fire hall that's made out of wood with burnt wood siding on the outside. So we're quite pleased with that. We've productized our offering for fire stations so that integrating both the structure and the envelopes, and we've since sold a second fire hall, which we're installing this fall. This building is another level of maturity from our box panels. This, in fact, is a 9-meter grid pattern, and we sold and engineered our box panel system to span a 9-meter grid pattern here. So this now opens up the opportunities to be able to sell mass timber in situations which would more commonly be better suited by concrete. We continue along the vein of selling into First Nations communities, and this is an Aboriginal healthcare center in London, Ontario, which we are delivering again this fall. The largest project that we have won so far is the Toronto Regional Conservation Authority. This is a 80,000 square foot post and beam structure, and we are delivering it and erecting it in mid-November of this year. So we had always had our sights set on a larger building in Ontario for the larger market space. We honestly believe that Ontario will become a center for the mass timber industry, at least in the whole eastern half of North America. We see tremendous opportunities to be able to sell buildings into the central United States and the whole eastern seaboard. So there are many, many opportunities that are currently in our pipeline. And so about 2.5 years ago, we started working on the construction of a new plant. These are photographs that were taken just the other day. It's a 133,000 square foot building. We have a capacity of about 45,000 cubic meters of CLT, 5,000 cubic meters of glulam, which is the equivalent to about 8 Brock Commons buildings per year, and will employ about 50 people and create about 240 jobs in related manufacturing, sawmills, transportation, and the logging sectors. So again, thank you very much, Nick and Raymond, for the opportunity to present. And I will be in one of the breakout sessions, I think room 3, and look forward to answering any additional questions that you may have.
Thanks so much, Patrick. Yeah, we're going to put you in room 2 just to have a series of that. But nice to hear about what you're doing with Element 5. Congrats on the new factory. Some amazing projects there. We certainly hope to see it expand, across Ontario, across Canada. It'd be nice to get a project in Ottawa. And fairly ironic that you're doing some of the fire halls too. Who would have thought that they'd start building those out of wood, right? So. Yeah. Fabulous looking projects, and looking forward to hearing a little bit more about what you're up to in the breakout room.
All right, thank you very much.
So next we're going to bring in Mark Gaglione, and he's from ELLISDON'S, and he is the building and materials science specialist over there. So he's perfect to talk a little bit more about mass timber and some of the projects going on. Initially trained as an engineer, Mark spent the early part of his career in private real estate development. Now with ELLISDON'S, Mark works in the construction science division, where he's focused on accelerating the adoption of emerging construction technologies, and he's played a central role in the proliferation of mass timber. So thanks so much for joining us, Mark, and we'll go over to you. Hopefully we got your last name close there.
You came close. There's a couple silent letters there that no one ever gets on the first go around, but that's just all right. Thank you very much, Nick. As Nick mentioned, yeah, my name is Mark Gaglione, and I'm from ELLISDON'S Construction, as you can see on my hard hat here. But importantly, there's some stuff here about what I do and things. Importantly, I'm an IPA drinker, and I understood this was a drinking event, so I hope no one minds that I'm going to be drinking throughout my presentation. And cheers if you're also drinking here with me.
Yeah, no problems, Mark. Something about wood and beer go well together, right? So
exactly, that's what I thought. Yes. So there's a little bit of repeat here, and so I'll jump through some of that pretty quickly. But whether you're in Ottawa or Toronto or Calgary, a lot of people kind of know the ELLISDON'S name and really associate it with these big buildings, usually concrete and steel, offices, hospitals, you name it. But when you dig through like the archive of what ELLISDON'S done, it really aligns with what Tim was talking about, how mass timber's been around for a long time and traditionally filled kind of more of a boutique place in the marketplace. So here's just kind of like a little snip of ELLISDON'S resume to up into about 2015 in the mass timber world. So a lot of museums, kind of fancy glulam structures, curvy ceilings. It's a showcase piece of the building in every case, essentially. And so that's where we were. And then some things started changing around the 2014, 2015 time period. A lot of that had to do with building code. A lot of that had to do with the supply chain as well, including Patrick's company and some others. So that's where we were up until about 2014, 2015. So what's happening now at ELLISDON? And so I'm in the construction scientist team. We're kind of like the R&D engine of the company. We're supposed to keep this big construction company at the cutting edge of emerging technology and what's coming down the pipe. And of course, we got the call on mass timber and we had to try to figure it out. And so where we brought the company to today, from kind of doing a lot of that small boutique stuff, here's what's going on to date. So at West, we just finished building a very large community center in the Vancouver area, Passive House. In Toronto, we have 2 big jobs on the go. The bottom one here is Centennial College. Out in Scarborough, it's 6 stories, like beautiful mass timber structure. And the top here is an early rendering of the Humber College job that we're starting to work on here with Kalishnikov, a BC fabricator of timber. And interestingly, this got put on hold because of COVID, but still going to get built next year, we're building the Canadian Pavilion at the Dubai Expo, which is now a 2021 World Expo. So lots of mass timber. These are the ones that are like unveiled to date. Lots more kind of in the pipeline. Very interesting kind of pursuits and research projects on the go with partners around the country and around the world, frankly. So that's what's happening now. And as you can see, we're kind of moving from that boutique kind of setup into kind of a bit more ubiquitous, where we're just replacing where you would traditionally use steel or concrete. And that's really the trend around the world. These are all real buildings, and the numbers here indicate how tall they're going. So, you know, we're feeding the lower rise stuff. At the same time, we're inching upwards into some of the other markets, which have traditionally been entirely dominated by concrete and steel. And there's a number of reasons for doing this, which the other presenters kind of eloquently went through. So Tim did a great job of explaining the acronyms. We won't have to do that here. But I wanted to show you kind of how this stuff is made. All of it kind of starts as similar to what you'd think of as like a dimensional lumber you get at a hardware store. Small pieces, but then those are assembled into larger pieces, stacked layer by layer. This is what's going on inside the plants that produce this stuff. You can see glue layers go in between. This element we're watching is like a piece of CLT, the cross-laminated stuff. Gets put into a press, shortly thereafter comes out, and now essentially what we've done, we've assembled all of these small pieces into essentially a bus-sized piece of wood, which can be used in all sorts of applications. Important to note, if it isn't obvious already, that these products are always used in combination where they make the most sense. So, you know, cross-laminated timber happens to be pretty good at being a floor panel and shear walls. Glue lam is very good axially, just because of the orientation of the grain. NLT as well, used in combination with other things. You'll notice in the back of this photo is like a big concrete core. It's important to note that like just saying you're doing a timber building doesn't necessarily mean it's all going to be timber, or that it should all be timber. We don't have to necessarily be purists about this. There's a lot of good reasons to use different materials where they make the most sense. And so this was a case in Toronto where they used a concrete elevator and stair shafts. You know, hybrid buildings make a lot of sense too. This was just like the completion photo of what Patrick showed earlier, the one he built on Golden Avenue. But steel hybrids are very common in certain parts of the world and becoming more common here. And there's good financial reasons for that, as well as, you know, some other considerations around headroom, material availability, and some supply chain constraints. It's just good to keep in your mind that, you know, we're kind of adding a material to the menu that you can select from. You don't necessarily have to choose one though. There's some good sense choosing a few in certain applications. Happy to get into the weeds on that if anyone wants to chat later. Also, it's not reserved for big buildings or commercial or buildings. You know, there's a lot of, there's mass timber entering the more traditional like light wood frame world. So on a photo here, you can see this is like a 6-story residential building on the West Coast where, you know, normally we'd see 2x4, 2x6 walls, and also you'd see like TGI wood joists across the ceiling in a conventional kind of wood construction of a residence. This was an application where it was a little bit of a remote job, and we swapped out all of the, this actually wasn't an ELLISDON job, but the developer swapped out all of the horizontal elements for mass timber, which enabled them to, you know, stand up the walls prefab, throw down all of the mass timber much quicker than you would be able to assemble the TGI joists. Things like that can start making sense depending on labor availability and like your proximity to the different suppliers. But there's lots of good applications in the residential world at all kinds of densities, even down into the 4 and 6 stories. So the rest of the kind of series of slides here is just a bunch of considerations. I sit at the contractor's perspective, so we kind of see projects holistically and the things that matter to our clients holistically. So I'll try to run through some of those and how it really impacts the construction process. So things you would want to think about if you're conceiving a job is headroom. There's a lot of ways to, a lot of systems out there. I'm only showing kind of a few here, but there's a half dozen others easily. And you know, the depth of the system sometimes matters to the client. And depending on the system you choose could change the depth of the system overall, which is something to think about. The grid spacing, there's a lot of different, options, I would say here. You know, there's box panels, whether you do CLT or glulam floors would also change this grid spacing. It's just important to note that there's an optimization exercise that generally has to take place before you conceive things like your grid. And so if you just select a grid, you won't necessarily be optimized for one product or another. So it's good to kind of have all your objectives at the table, and you can kind of start pulling in those key stakeholders that can really advise on what makes the most sense. So if the grid shown here is maybe it fits well for steel, and that would give you the best bang for your buck for steel, different grids might give you a better price for timber or concrete or vice versa. Acoustics is not something that was mentioned too much so far, but it's a very important issue in the mass timber world, simply because people love seeing the wood. And if you love seeing the wood, and the wood is also the structure, you're kind of left with treating for acoustics elsewhere. And oftentimes that means above the wood, so on top of your floors. So we end up looking at a whole host of different systems, from toppings to membranes to, we call like the concrete topping like a wet trade. You pour it wet, but you can also, there's some dry options out there that can be effective and cost effective even. So acoustics are a challenge, and especially when you start talking about residential, because if you want to see wood in your bedroom and there's a bedroom right above it, we're going to need to make sure that you're also not hearing when the person above you gets up out of bed. So those are a couple considerations. We talked about how controlled and precise it is. Nice thing is, I mean, we build a lot of concrete buildings traditionally, and there's this kind of conversion step where the architect usually designs everything in 3D, but then translates it down to 2 dimensions so that someone out on site can read the drawing and build the formwork. And then the formwork kind of translates it back to 3D. So there's this kind of conversion step that always takes place between 2D and 3D. And it's really like, it's a source of, it can be a source of error, and it's certainly a source of different tolerance, poor tolerances sometimes. Nice thing about wood is that the designers, the engineers, the architects, their models are speaking directly to these machines. And so that conversion step doesn't exist. And so that kind of source of error kind of gets removed. Really nice to be able to design for manufacturing. talk about construction sites becoming assembly sites. And here's kind of one of the cruxes of it. So concrete building, you have all these posts that kind of hold up the floors while our concrete's coming to strength. You kind of see that as you drive around different cities. Wood, you don't have that. The wood comes to site full strength, of course. So you can kind of start your next activity a little bit sooner. Give it, say, 3-4 weeks sooner. This is a bit too much writing to go into in any detail, but the point here is that, I mean, although the wood can move really fast, it's important to actually like only speak about the whole project. How fast is the project moving? And so if the wood moves fast, the only kind of way we're going to make our project actually end earlier, which is what the client really cares about, the only way that's going to happen is if we actually find ways to accelerate everything else. So the wood is probably in the one of the first 4 or 5 activities that would happen on the site. There's at least another 35 to 40 afterwards that if they move at the conventional rate, the project's probably going to end on the same day. So a lot of our focus is figuring out ways to optimize downstream trades and find ways to move them along at a rate that justifies the use of the wood, or at least so we can capitalize on some of the speed. It's pretty straightforward though. The wood only moves as fast as your crane moves, and so we can kind of get into a lot of analysis about that. Costs are another huge topic. It's usually the only thing anyone cares about when you start talking about like the very big buildings where institutional developers are looking at bottom lines. And so it's very case by case, depends on what market you're in, depends on what you're building. The important thing to know is that by switching from, say, concrete to wood, you're not just changing one line item, you're actually changing every line item of your budget. Some of them get more expensive, say maybe your mechanical system, because you have to change your fire suppression or your HVAC costs or your electrical system. Some of them get cheaper. You know, your foundations might be lighter. You don't have the drywall scope that you would normally. So big balancing act, a lot of up and down arrows to determine, you know, if there's an overall cost premium. And so we spend a lot of our time figuring out those details. I'm happy to go through the numbers with anyone afterwards. So this is a little bit too detailed. I'm going to skip over that one. But that, or just, there's a lot of code implications depending on how tall of a building we want. And this is a little bit variable depending on where you are in the country. But the gist of it is if you're below 6 stories, it's a lot easier. If you kind of between 7 and 12 stories, there's some rules that you can follow, which kind of make it easy. And if you go above 12, you're into a situation where you're called an alternative solution, which is not the end of the world. It's been done many times. It adds some complexity and some costs, which not deal breakers though. There's lots of precedent setting at all of these levels today. So where can you get this stuff? Where can you buy it? ELLISDON is generally a buyer of a lot of this. And so, you know, there's a maturing supply chain here in Canada. Patrick's company, Element 5, is one of the growing players in the Ontario marketplace, very big player. There's certainly some in Quebec and some in BC. So this is kind of the lay of the land currently in North America. If we made a map like this, say 5-6 years ago, it would look very different. There'd be a lot fewer dots, and it kind of shows where the market is headed and kind of how the supply chain is maturing and filling in domestically. Of course, the European market exists, and they have some capacity and some, you know, years on us in terms of building up that capacity. So there's a lot of interesting options, a lot of projects that get supplied from Europe or a combination of domestic and Europe. A lot of interesting things we can talk about there. So a couple last points here. How does this change your construction site? Well, we have to care a lot more about rainwater. Usually we just let our concrete structures get rained on because it's not going to do any harm to the concrete. But we have to be a little bit more deliberate, a lot more deliberate with how we manage water on our sites, given that they're wood structures. And why is this? Well, we want to avoid a couple bad things that really bad things that we wouldn't want to happen, like any kind of decay or any kind of mold. Those ones, of course, we're going to avoid. But even more not importantly, but something that would happen earlier than these is aesthetic damage. You know, you don't want rainwater to happen and leave behind water staining, or it to pick up some kind of steel debris and leave a kind of a black stain on it. So we come up with plans, and we really plan for all these eventualities. What if it rains? What if it snows? You know, what do we do? And there's all kinds of systems not shown in this photo on how to deal with that. Again, all that plays into the cost scenario. So here's a couple of strategies. We don't do this ever, but this is happening in Europe now. I would love to put a roof over our building, but the economics don't make sense for us just yet. There's protection options, membrane sealers, things like that. And then of course, you know, a lot of times we make mistakes and we have to try it, we have to fix it out. We're honest about that. Checking is something that happens in these wood buildings, and it's not I mean, sometimes people see cracks in wood and they think it's like such a bad thing, but it's like, it's a very naturally occurring phenomenon in these wood products. Not a structural issue, like almost 10 times out of 10. And there's all kinds of engineering and guides and things to figure out. You don't have to phone your structural engineer in the middle of the night to wake them up. Fire is of course another thing that's becomes important on our site. And we just have a number of strategies that we implement anyways, but they become on a concrete site, but they become very important. Taking the welding off site, increasing security, things like that. And lastly, the last point I wanted to make was just to reinforce the carbon piece that you know, Tim tipped us off at the top of the night here. And so there's really two pieces which we're talking about here. So there's, you know, Tim really reinforced the stored carbon, the sequestered carbon in the wood, and that's a good thing. We want to maximize that. The other piece I want to bring up is like the embodied carbon. So it doesn't like matter what material we use, if it's steel, if it's concrete, if it's wood, there's like an associated embodied carbon piece with that. It's you know, it takes a certain amount of energy for the sawmills, the trucks still are driving. There's a carbon penalty to that. The point being that the embodied carbon of a single element of wood, an equivalent single column, say for example, is significantly less than like the equivalent steel or concrete. And so you say like, okay, how much less? Like, what is the issue here? So we've done like a whole bunch of life cycle analysis on this kind of stuff at the building scale, taking into account a lot of things. It comes out to about 30% less embodied carbon alone. And this is ignoring all of that sequestered benefit that was raised earlier. So even if we don't take advantage of that sequestered number in our calculation, still like from an embodied standpoint, we still come out in front on a carbon balance. So, I mean, that's an important thing, and something that we generally reinforce to all of our clients when they're considering this. And, you know, this is an example on the left here of a building where that calculation made the difference between selecting a wood system versus selecting an alternate. So something that's becoming more and more important moving forward for sure.
That's great, Mark. Thanks so much for diving deep, and there's a way that people can get in touch with you there, and feel free to add on chat there so people have your details. Congratulations on the great work that you're doing with ELLISDON and pushing them forward into the next century and into a little bit more sustainability. And it's certainly exciting to hear about some of the projects you're working on. So thanks so much. And I'm sure you'll be able to go a little deeper on some of the embodied carbon issues during your breakout room there. So look forward to that. So we're going to go to our final speaker of the night, and we've got Andrew Melchers, who's president of In Engineering, and he'll be giving us an overview of timber framing. And the timber framing is making a resurgence, both aesthetically pleasing and structurally suitable for many different types of projects. So Andrew is a structural engineer with a passion in wood design and improving sustainability in construction. He is president of In Engineering and Surveying, which is a new consulting firm that provides integrated engineering and land surveying services. The vision of In Engineering and Surveying is to utilize the latest developments in 3D modeling, virtual design, and virtual construction to improve the engineering process. They're based out of Brockville, and they're also one of SmartNet Alliance's newest members. So want to welcome them into the membership. And over to you, Andrew, to talk a little bit about timber framing.
Great, thank you for the introduction. We've had some awesome speakers tonight. I've been absolutely blown away. I'm very passionate about mass timber, but I'm also a small town engineer. So we're also going to scale this down a little bit into what a small town engineer does to try to be more sustainable. One of the things I'm really passionate about is traditional timber frame structures. So you can see here a couple examples, and that's what we're going to talk about tonight. So I'm just going to bash through my introduction. We'll talk about some modern timber frame buildings that I'm working on. I also review a lot of historic lumber buildings and some limitations I have with that, and how I'm trying to work to solve those problems from an engineering perspective. So I graduated in 2011, did my master's, finished 2014, and I became a professional engineer in 2015. I bounced around a lot with a bunch of different firms, then realized I just wanted to start my own company. Founded my company in 2018. In 2014, I biked from Vancouver to St. John's, which was an awesome trip. And if anyone ever wants to talk about that, we can talk about that at a later time. And in 2018, I was Brockville in area's Young Professional of the Year. So in 2018, I started my company. The purpose of the company was just to try to give back to the community a little bit. I think our role as engineers, first and foremost, is to serve the community and make sure that buildings and structures are safe, and you know, the average person doesn't think about all the work that goes into the average into a building. In April of this year, I purchased Colette Surveying, and so I merged my company with theirs. And then 5 days later, we're shut down due to COVID, which was pretty awful for the first few days. But then it really, you know, kind of slowed down work and let me get into the gears of the merger and acquisition. My goal, in engineering, it just comes from intelligent, intuitive, inspired. So I think, you know, as engineers, we should always try to maintain that vision. I had this goal of trying to modernize engineering. All those other firms I work with, they're all stuck in the 2D plan world, and you know, we really need to get out of 2D plan and get into 3D modeling, virtual design construction, and you know, that will increase the efficiency of our construction process and therefore increase the sustainability of buildings. You know, if you ever been to your average construction site, there's a lot of waste that goes on in a building. You know, like that 3 inches of a 2x4 that they cut and threw out, like maybe we could save that if we did a little bit of modeling first. So we are located in Brockville, Ontario. It's just on the St. Lawrence River, south of Ottawa. You know, I'm surprised there's not more engineering firms here, because, you know, we can get to Kingston, Cornwall, Ottawa anytime we want. Maybe don't tell everyone my secret, but that's kind of my goal for the company. I do have a personal goal of being, you know, maybe Eastern Ontario or at least Southeastern Ontario's leading mass timber design firm. I'm trying really hard to get the first mass timber building in the area. Every single building, whether it's a house, a shed, or we're working on a fire hall, I try to tell them, hey, let's do this mass timber, right? But I haven't got one yet, so I'm still working towards that. So timber framing is the original gangster mass timber. So we've been using wood construction for a long time, which Tim kind of touched on a little bit. So that pagoda there in China was built in 1056, and that's traditional timber framing. I don't even think don't quote me on this, but I don't even think they use nails. It's all joinery. So, you know, so bringing that back into the modern realm, you can see on the right, that's a model I'm working on where we're doing a timber frame building, or a timber frame house, and that's their great room, kitchen, the grand entrance into the house. We're doing all traditional joinery, so wood pegs, big timbers, big natural timbers. And, you know, it's really aesthetically, in my opinion anyways, it's very aesthetically pleasing at the end of the day. So when you walk into this house, you're gonna have this grand timber entrance. So in order to do this from an engineering perspective, we used the CSA code 086, that's engineering, design, and wood. And it's not really written for timber framing. So as an engineer, I do my best to interpret the code to use it for timber framing. There is no mass or traditional timber framing CSA code that engineers can rely on. And so our process, you know, we work with the timber framers. So, you know, if you want a timber frame structure on your house, you would probably go to a timber frame company. They would draft it, design it, tell you the price and everything. You would say, yes, go ahead. But that comes pre-engineered. So we kind of provide that pre-engineering to these timber frame companies. So we will see the shop drawings 3D model. The timber framers, they love 3D modeling because they 3D model all the joinery that they have to cut by hand. They know exactly what they have to build and fabricate. But it's also great for us because from an engineering perspective, we use that to do our 3D analysis and modeling. So we import it into structural modeling software. The brutal thing is, you know, the structural modeling softwares out there haven't really caught up to using wood and CSA 086. So we have to analyze it in the software, export all the loads and forces and everything. And then we have our own MathCAD, which is a very cool, well, it's cool for an engineer. It's a very interesting software where we can produce detailed engineering calculations. And from that, we determine all the load resistances for the members to make sure the building's safe. We also, you know, I will do hand checks on certain areas. So a lot of times, like the bottom cord and the timber frame bent, that's there's a high tension there, and if timber's trying to split apart, it's not really the greatest. So sometimes we have to sheet a bit and use a steel joint. And so, you know, we do model in the software, but we also do hand calculations as well to engineering practices. So here's what we kind of do in MathCAD. I have all this pre-programmed. I think I have almost all of CSA 086, engineering design and wood, pre-programmed in MathCAD right now. And it's just as simple as putting in lengths, spans, and member sizes until, you know, one of those structural analysis softwares catch up and we can do it inside the software. Waiting for that still, but hopefully someday. So there are a lot of code challenges. I think Mark touched on that a little bit. It's kind of tricky. So in a small town engineering firm, we skirt the line between like a real building design and part 9. So part 9 is like for small buildings and houses, and it's a prescriptive based performance. So that's where you get your architectural designers. They can do structural design as long as their beams don't span more than 4.5 meters. And so, you know, we kind of skirt that line. Like we're trying to figure out what's part 9, what's part 4, which is like a structural engineering realm. And so, and a lot of these timber frame structures are hybrid. So we kind of mix light frame walls with timber frame grand entrances. And so it's a bit of a challenge, but I absolutely love working with timber. I think it's beautiful when it comes out at the end, and that's kind of what I'm working towards personally to specialize in. Also, the great thing about timber frame structures is, you know, you can't put an architectural seal on it, so it has to be designed by a structural engineer. So it's also a great niche to become part of. So here's a project that was just finished in December. This is downtown Brockville. They have an outdoor hockey rink that they just put a steel roof over, which, funny enough, back when I was like an intern at a company, they were involved with the project. I was like, we got to do it in mass timber. We got to do it in mass timber. And I was like, why would we put an ugly steel building on it? But unfortunately, the price difference was a little bit too high, so they put an ugly steel building over top of it. But the steel above the roof, water condenses on it and drips on the ice and causes imperfections in the ice surface. So, but if they went to wood, we wouldn't have had that problem. So, not to say I was right, but probably should have went with wood. So this is downtown Brockville. So we added this pavilion structure. P&G is they had a massive plant here in Brockville, and they're closing in the next few months. So as a parting gift to the community, they've been here for a long time. They wanted to build something for the community. And so this building has change rooms for the hockey rink, a Zamboni garage, and a little canteen. And I sold them on doing, like, hey, we got to do a timber frame accent pavilion there. And so that's what you see there. It's all done in Eastern pine. And there's some cool hidden knife plates to keep the posts up off the ground. And it's definitely worth a look. The tower you see there, it's kind of hidden behind the timber frame, is modeled and scaled off of a church that they demolished, like just next door. And so it's kind of an ode to that church that they took down, but also it shows the timber framing, and it's a great community piece. Here's the 5 Mile light. So 2 years ago, it got struck by lightning and burnt down to the ground, which is, a lot of people along the river were very disappointed in that. So I got involved with a project to rebuild it. And they're like, you know, everyone's like, well, how are we going to do it? I was like, well, we got to do a timber frame, because if we're going to do this historical recreation, like, they wouldn't have steel columns. And then, you know, someone puts up their hand, they're like, well, steel would be much cheaper. I'm like, no, like, it's a historical recreation, you know, we have to do it in timber frame. So I convinced the community to put the extra bill to do a timber frame. It's, you know, 80% through construction right now. So that's the picture on the right. I structurally modeled it and everything. And it's literally on a rock in the middle of the St. Lawrence River. So if you have a boat and you're going by it, you'll start seeing it. My future goal for this thing is it's just gonna be an empty building, but I kind of want to put an Airbnb in it. So if you're interested in that, then maybe we should talk. So here's a couple more structures. So on the left is a massive barn I'm working on that this guy, he just wants a massive timber frame barn. So I'm just starting that project. And on the right, we have this hammer truss style front entrance. And so, you know, where these timber frame things come in is they're great architectural accent pieces to the front of your house. And like I said, I work with a lot of the timber framers in the area to make these. So going on to historic buildings. So historic buildings are a challenge when it comes to wood, and it's something I'm working to solve. So, you know, I forget the year, but at some point, I thought I had the date in there, but I think it was in the 70s, you know, the Canadian Standards Association came up with lumber grading certification. And that just ensures that the quality of the wood is good enough to use for structure. But it also means that every building built before 1970, from an engineering perspective, is technically not usable because it's all ungraded lumber. So you go into a 100-year-old building, it's ungraded lumber, you're like, well, if we're gonna renovate this, I can't use it structurally. And so therefore, we either have to bin it in place or tear down the building. And so that's why you see a lot of these historic buildings getting torn down. It's just like structurally, there's no way to save it. The other challenges is timber framers have to source their lumber from a graded source. So they can't go out, cut down that, you know, 100-foot jack pine and turn it into a beam because it's ungraded. All the lumber graders are in like where the sawmills are, and they don't really do house calls for a small engineering project. So this is a huge challenge that I face on a regular basis. I'm working on another project where there's just like a little timber frame accents and they're mildly load bearing, but the contractor sourced ungraded lumber, and I've been after the contractor like, this lumber has to be graded or I can't put my stamp on it. And they actually had to pay to have a lumber grader from Quebec, or not from Quebec, from Northern Ontario, drive down to Brockville, grade the lumber on site. And I don't know how much that costs, but that's not fair to the contractor either. So that's a huge challenge that we face and something I'm working to solve. Yeah, there it is. So in the 80s, the NLGA standards started. We divided everything up into species and grade just so we can do it structurally. One cool note that I rely on a lot is starting in so if the building's older than 1860s, it's probably local Eastern Ontario garbage lumber, not garbage, but like northern species, which is the least strong lumber. But if after the 1860s, you can kind of start suspecting, well, maybe it's Douglas fir, and hopefully. I am not a lumber grader, but I'll get on that in a minute. One really interesting thing, so SPF lumber you get at the hardware store, spruce pine fir, that's what SPF stands for, but Eastern white pine is not categorized under spruce pine fir. It's actually northern species. Spruce pine fir all comes from the West Coast. So when you're talking about embodied carbon, a lot of that lumber is coming from the West Coast. So that's one thing that a lot of designers get hung up on. Like, well, it's pine, it's SPF. It's not. Yeah, so when you're renovating an old building, you know, there's some code stuff. You can grandfather it, like people say, under Part 11. But if you're increasing the loads or the occupancy or changing things around, then all of a sudden, all that ungraded lumber is no longer useful. The National Lumber Grader Association, they don't do field inspection. So if you're trying to save an old historic building, they're not going to come there and grade every single piece of lumber. There are alternate compliance paths you can use that will, you know, you can field test every single stud or every single joist, but that's not economically feasible most of the time. And then the funny thing too is a lot of these old buildings are under federal buildings, and they fall under the National Building Code, which does not have a grandfather clause. And so I'm actually an Army reservist at the Brockville Rifles, and our building is going under major renovation. And because we can't grandfather everything in, like it's the renovation, like from my perspective, I'm just like, this is crazy, but that's just what the building codes allow. So some limitations and how I'm trying to solve those. So I talked about how lumber grading is super difficult for an engineer to get an old building passed. So I've actually been in talks with the lumber grading associations in the area, and I'm trying to enable structural engineers to be able to field grade lumber. There's a few things I got to work for. This is probably going to be a lifelong project, but I would like to think by the end of this project that we can start saving more historic buildings by allowing structural engineers to grade lumber. The engineering design and wood code, it's focused on softwood species. So theoretically, I can't use any hardwood for anything structural, which I think is a little bit interesting. And then just getting into more complex engineering, like partial fixivity of timber frame connections. So in a steel connection, we can do like, you know, I won't get too technical, but in steel we can do partial fixivity and really design efficiently. But in timber, we can't quite do that yet under CSA 0886. At least I haven't found a way, anyways. And so those are some limitations that I'm working on. It's a challenge I'm about to take on. As you can see, I'm pretty young and I got lots of time to figure this stuff out. So that's the end of my talk. There's some contact information. Feel free to reach out. And if you want to chat more about small town timber frame projects, then meet me in one of the breakout rooms.
Thanks so much, Andrew. Definitely excited to hear about some of your projects there. Nice to see some small scale stuff, and that you know, there's still space for that. And I'd definitely be excited to check out that Airbnb. Absolutely, sign me up for that. So that could be a good getaway. Striking photo of that on fire too. And thanks for bringing up the codes too. Perhaps you can go a little deeper in your breakout room, and anybody who's interested to talk about the building codes, because I know that's something that is potentially holding some innovation back. So that may be a good topic in your breakout room. So I want to thank everybody, thank all the speakers so much for a great evening. We are going to go into the breakout room session, but we won't record that. So we'll kind of hit pause on the record. Now remember that we will be getting this presentation out on YouTube in the next couple of weeks. So if you wanted to share it with any of your colleagues, family, friends, you'll be able to do that. And that's on our YouTube channel that I've shared in chat. So